Okay, so we've got the integral here, x squared times the inverse sine of x with respect to x, and the parameters of integration are from 0 to 1. Now, looking at two terms here, x squared inverse sine of x, or arc sine of x, whichever way you want to call it, two terms going to be integration by parts. So let's start off by putting the formula for integration by parts. So u dv, so one of these is going to be u, one will be a dv. Then we'll get part of the answer, which is uv, and subtract the another integral, which is v times du. So which is going to be v, which is going to be u, which is going to be v. So with u already in here, and we're going to have to integrate one of these. Integrating x squared is going to be the easy one, and inverse sine of x has a standard derivative anyway. So let's go straight into that. U equals inverse sine of x, and du, so inverse sine of x has the standard derivative of the reciprocal of the square root of 1 minus x squared. So u and du, we've already assigned those variables here already, so now we need to do the v and the dv. So v and dv. So the dv, which we've got in here, is going to be the x squared. So now for the v, we just need to take the integral of x squared, which is 1/3 x cubed. Okay, so let's just plug that in here now and see what we end up with. So this equals from 0 to 1 v du, so that's going to be this, uv, so u times v, so that's inverse sine of x, 1/3 x cubed, so that's 1/3 x cubed inverse sine of x, so that's our uv, and we're going to subtract another integral, v times du. So v is 1/3 x cubed, so with the x cubed and the 1/3 we can bring the 1/3 out front and go x cubed. We've not changed the value of anything here yet. And du is this one here, 1 over the square root of 1 minus x squared. So basically all we need to do here now is just put this on the bottom. The 1 on the top is not going to make any difference to the x cubed, so we'll just put this square root term on the bottom, 1 minus x squared, and then dx, not forgetting the dx. Okay, now this one here is part of the answer, so with the parameters of integration we can evaluate that from 0 to 1. So let's just do that. So when we have got 1 in here, x cubed, so 1 cubed is 1, times a third is a third. Inverse sine of x, when x is 1, that's pi over 2. So basically what we're looking for is sine minus 1 of 1 equals pi over 2. So that's pi over 2, and that's a third. So if we times that by 1/3, we get pi over 6. So this part of the answer here is pi over 6. So let's just put that down. Let's put that here. So we've got pi over 6. Now we've got this one here. So minus 1/3 times this new integral. Now this one here, we've got an x squared and an x cubed, so a u sub might work, but even better than that, we could go for a trig sub. So if we let x equal sine of theta, so let's put that down here, x equals sine theta, dx equals positive cosine of theta. So I don't need that positive there. So dx equals cosine theta. So we could put that substitution into there. So let's just plug that in there straight away. So 1/3 times the integral. Right. Just put the parameters of integration back in there now, because we're going to need to just change those a little bit. So if x equals sine theta, when we put 1 in there, we need what the sine is going to be 1. So therefore we need to put in there pi over 2. So sine of 1 pi over 2. And for 0, we get 0. That's our 1 and that's our 0. Okay, so now we put pi over 2 and we put the 0 back in. X cubed, well, x cubed is going to be sine cubed theta. And then divide that by the square root of 1 minus x squared, which is 1 minus sine squared theta. Okay, and then the dx is just going to become cosine theta d theta. Just squeeze that in there. Okay, right. Let's just put a line on that. Square root of 1 minus sine squared theta. Well, we know the famous trig identity. Just write that on here. Sine squared theta plus cosine squared theta equals 1. So therefore, cosine squared theta equals 1 minus sine squared theta. And then we take the square root of both sides. And we get cosine theta equals square root of 1 minus sine squared theta. And that's going to come in pretty useful for us here, because for the cosine theta we could just put that in there, which will then give us a cross cancellation of this one, because those two are of the same value, except one's a reciprocal, one's in the numerator. So basically we're going to get these two to cancel out. So let's write that integral out again. So now we've got pi over 6 minus 1/3 0 to pi over 2, and it's just sine cubed theta d theta. Okay, so now what we need to do now is how we're going to integrate this sine cubed theta. Now we could go the long way around and keep breaking that up into sine squared theta, sine theta, or we could use a trig identity. Now there's a famous trig identity for involving sine cubed theta, so which is like this: sine 3 theta equals 3 times sine theta minus 4 times sine cubed theta. So sine cubed theta we see we got here, but it's with a 4 and all these. So what we do is now, let's bring the 4 sine cubed theta over to this side. So that changes the sign of that one. This one will stay here. And then we'll bring this one over this side, give minus sine 3 theta. Then all we need to do now is just divide through by 4. Sine cubed theta equals 1/4 3 sine theta minus sine of 3 theta. So instead of taking the integral of sine cubed theta, we can take the integral of this much easier. So if we just plug that in there, we've not changed the value of anything, and then we've got ourselves an easier integral to do. So now we've got pi over 6 minus 1/3, and we've got 1/4 here, so we've got times that by 1/4. We can bring that more constant multiple out front. Then the integral from 0 to pi over 2, 3 sine theta. Let's just give ourselves a bit more room here. Let's just bring that 1/3 times 1/4 to 1/12. Give ourselves a bit more room. So 1/12, 0 to pi over 2, and then 3 sine theta minus sine 3 theta d theta. Okay, now we're ready to integrate this. That should be pretty straightforward with the sign on both of those. So now we get pi over 6 minus 1/12. Okay, let's go straight into the integration. So integral of sine theta is negative cosine theta, and times by 3, so it's minus 3 cosine theta. And then take the integral of negative sine 3 theta. So now we're going to subtract, take the 3 theta out, we get 1/3, and then cosine of 3 theta. The input doesn't change. Okay, now the minus here, when integrated, that will now make this one a plus. Okay, and then we go from 0 to pi over 2. Okay, so now we're ready to evaluate. So we got pi over 6 minus 1/12. Okay, minus 3. So when cosine is pi over 2, it's always 0. So all these first ones are 0. So we can just put a 0 in there at the beginning. So let's put a 0 there first, and then evaluate at 0. Because cosine of 0 is pi over 2. So minus 3 times cosine 0. So that becomes, sorry, cosine of 0 is 1, not pi over 2. Pi over 2 thinking no one. So cosine of theta is 1 when it's 0. So minus 3 when cosine 1, so that's minus what? Minus 3. So we've got minus 3 plus 1/3. Cosine 3 times 0 is still 0. So cosine of 0 is still 1 times 1/3, so it's just 1/3. Okay, now let's evaluate this out. So we've got pi over 6. Okay, let's work this out now. So we've got pi over 6 minus 1/12 times 0 minus 3 plus 1/3. Well, minus 3 plus 1/3 is minus 8 over 3. So that gives us plus 8 over 3. So that's 8 over 3. Let's just make that clearer. Okay, so that's 8 over 3 times the 12, that's 8 over 36. So 4's into that, go 12, go 9, 4's into that, go 2. So basically what we've got here now is pi over 6 minus 2 over 9. And that is the answer to our integral. Quite an interesting integral there. Integration by parts, do a substitution, trig sub, and then we use the trig identities here, and this big trig identity here to help the integral easier gives us our answer, pi over 6 minus 2/9.